Good afternoon, everyone. Welcome to the first PU Physics Test 2 paper discussion. The topics are laws of motion and motion in a plane, right? Let me share my screen now. Is the screen visible to everyone?
Yes, sir.
Excellent. All right. And both these chapters are very, very important chapters as far as your first PU examination is concerned. They come under this broader topic called mechanics. Let's get into the questions now. The first part is very short answer questions where you are expected to answer within a line or two. Each question carries 1 mark. What is a measure of inertia of a body? Any guesses what the answer is?
Mass.
Absolutely.
Mass.
In a straight line motion, in a 1D motion, the inertia of a body is going to be mass. Later, you will be learning in rotational motion, the inertia of the body will be because of a term called moment of inertia. So in this context, the answer is mass. Mass is a measure of inertia of a body. Is that clear?
Yes, sir.
Excellent. Let's go to the next question. When is the magnitude of resultant of a vector's maximum?
Okay.
Yes, students. When is the magnitude of resultant of two vectors maximum? If two vectors are P and Q, then how do we write the magnitude of the resultant? Any guesses? Resultant is given by root of P square plus Q square plus 2PQ.
The answer when cos theta is equal to 1, that is angle theta is 0 degrees.
Absolutely. So when the answer that you're expected to write is when the angle between the two vectors is 0, the resultant of the vectors becomes maximum, right? That's exactly what you're expected to answer. Yes, Emmanuel, as you said, going by this equation, if P and Q are two vectors, then the resultant is given by root of P square plus Q square plus 2PQ cos theta. So resultant depends on the angle theta, or in other words, cos theta. So R will be maximum when cos theta is maximum. And what is the maximum value of cos theta? 1.
1.
That happens when theta is equal to 0. Clear? Let's move on. During projectile motion of a body, which component of velocity of the body remains constant?
Horizontal components.
Horizontal component of what? Velocity, right?
Yes, sir.
Excellent, excellent. What is the reason for that?
There's no external
Because there's no
force or
external force being
acceleration in
applied
that
on the
direction.
horizontal direction.
Yes, yes, Emmanuel, yes, Jeril. Because there is no force or acceleration along the horizontal direction, the velocity in that direction remains constant. The only acceleration that is going to act is what?
Gravity,
And that acts in
vertical component.
vertical component. Therefore, the horizontal component is not altered, right? So as you can see, the horizontal component, let's say I call it as Vx I cap, that remains the same throughout the journey of the projectile. Whereas the vertical component keeps changing. The only acceleration that's acting is because of gravity. So your answer that is expected of you is the horizontal component of velocity. So each question carries 1 mark. Let me ask a few questions here. At the topmost point, what is the velocity?
U cos theta.
It's equal to u cos theta, right? The vertical component becomes
0.
0 at the topmost point. And the total velocity at the topmost point is
U cos theta.
u cos theta, and it is minimum. If you consider the whole journey of the projectile, at the topmost
Yes.
point, the total velocity is minimum. And the total kinetic energy of the particle at the topmost point is
Minimum.
minimum, yes. So I have a couple of them who have raised hands. May I know? Is everybody fine? Is my voice audible to everyone?
Yes, sir.
Excellent. Excellent.
Yes.
Let's move on. Next is short answer questions. There are 4 questions. Each question carries 2 marks. Of course, all these questions which have appeared in your paper are questions which we have asked in the board examination of first PU, right? Which year each question came, I'll send you a document on that to the group, okay? So you'll get an idea. Anyways, now we are just going to discuss the questions here. Mention any 2 advantages of friction. Can you share?
It helps in walking.
Yes.
And
Life would
helps
not-
to stop a car.
Yes. If I want to apply the brakes, without friction, the car wouldn't stop. Yes.
Without friction, the car wouldn't even move.
Absolutely. Absolutely. So without friction, there'll be no rolling that will happen. Rolling is happening. Rolling of the wheels happens only because of the friction between the tire and the road. Right? Excellent. Excellent. That should be good. Okay. So let's look at, what all possible answers you could have written. Friction enables us to walk on the ground. Absolutely. Friction helps in motion of the automobiles. Yes. Brakes of the vehicles will work only due to friction. Matchstick is lighter due to friction. Board or paper writing is possible only because of friction. So we could list a lot of examples. Just 1 or 2 of them would be good for this question. Move on to the next one. Mention the expression for centripetal acceleration and explain the terms. So all that is required is you to mention the centripetal acceleration expression. Could you tell me, guys?
Expression for the centripetal force, sir.
Centripetal,
MV
not force,
squared by
centripetal
R.
acceleration. What is centripetal force?
The force acting in circular motion.
The circular paths with uniform
Right.
velocity.
So what is it going to be? Quantitatively, what is its value?
Zero.
No. Go ahead, ma. Tell me, guys. Centripetal force is mv square by r, correct?
Yes, sir.
Yes. So a body undergoing circular motion will necessarily need to have a centripetal force. Only then the body can undergo circular motion. And centripetal acceleration is a radial acceleration which is directed towards the center, right? So when force is mv square by r, if I write the force as mass into acceleration, the mass gets cancelled. So A is nothing but v square by r. Okay, that's what is expected of you. As you can see here, centripetal acceleration, or you can call it as radial acceleration, is v square by r. And so that's what you need to express, mention, and then you should explain the terms. So what is v, what is r, and what is a? So v is the linear speed of the particle, r is the radius of the circular path, and a is the radial acceleration of the particle. Is this clear, students? You may take it down.
Yes, sir.
I'll give you a minute.
Yes, sir.
All right, let's go to the next question. Question number 6. Write the expression for horizontal range of a projectile. For what angle of projection is that value maximum? So all that you need to write is just, the expression which we know, right? Nothing else
U
may be
square
needed.
sine 2 theta by g.
Exactly. U square sine 2 theta by g is what is expected. Right? And when is it maximum?
sir.
R is maximum and theta is?
When 45 degree.
Yes. You're not expected to write the reason. You need not. But for my own interest, I want to know how do you get theta equal to 45?
So because 2 theta is 90 degrees and the maximum value for sine is 1. So sine 91.
Excellent, excellent, excellent. That's great. All right. So if you see R reaches maximum and sine 2 theta is 1. Sine 2 theta is 1 when T2 theta is equal to 90 degrees, which means theta is equal to 45. Absolutely right. Yes, Jati. Perfect. Let's move on to the next question. State and explain triangle of vector addition. Yes. Who can tell me that?
That when two vectors are represented in both magnitude and direction by two sides of a triangle, the resultant would be the third side in the opposite direction, starting from the same point.
Yes. Perfect. Emmanuel. So if I have two vectors, let's say this is vector A and this is vector B. These are taken as adjacent sides of a triangle taken in order. Let's say this is A, this is B, this is C. And the resultant of the two vectors is given by the third side taken in the opposite order. So resultant R vector will be equal to A vector plus B vector. Absolutely. Right. So you'll be expected to write the definition, also, the statement and also the diagram. Right? Triangle of vector addition states that if two vectors can be represented in magnitude and direction completely, or you can mention the word completely as well, okay? If two vectors can be represented in magnitude and direction by two sides of a triangle taken in the same order, then the resultant vector is represented completely by the side of the triangle taken in opposite order. It should be the other side of the triangle taken in opposite order. Of course, additional point is the resultant of two vectors is maximum when they are in the same direction. That's fine. That you could write it, you need not. That's fine. So this is what you are expected to write. So A vector plus B vector will be equal to R vector. All right. Perfect. Any doubts on this, guys?
No, sir.
Yes, sir.
Now let's move on. We have short answer questions. Each question carries 3 marks and you have 3 of them. So total is 9 marks. So the first of the 3 mark questions is derive an expression for maximum height of a projectile.
U square sine square theta by 2g.
Yes, that's
But-
what we need to derive. Okay. So where do we start? You can do it in 2 ways. I'm going to show you one of the ways here and also do it by another way. Okay.
Okay, sir.
If I'm fast, please let me know, guys. If you want me to wait until you copy it down, please let me know. Okay. Fine. So as you can see here, we have the representation here. You have the projectile which is undergoing projectile motion. If the initial velocity is u and the angle of projection is theta, then what is the horizontal component?
U cos
U
theta.
cos theta.
U cos theta. And what is the vertical component?
U
Sin
sin theta.
Right.
Sin theta.
Correct. Okay. Now, the vertical height at any point on the projectile is taken as y, and the horizontal distance from the starting point is taken as x. Because it's moving in a plane, it will be represented by 2 coordinates, x and y. And your maximum height, is it a y value or a x value?
It is
It's a Y value.
value, sir.
Y value, absolutely,
Y
right?
value.
So y has to be equal to h, correct? And what is the time taken for reaching the maximum height? If the total time of flight is capital T, then the time taken to reach the maximum height is what?
T
T by 2. Is it not? Time of ascent is equal to time of descent. Time of ascent is T by 2. Time of descent is also T by 2. Here we are making use of the result of time of flight, okay, which we know is what? U sin theta by G. We are allowed to do that, all right? And what is the initial, what is the acceleration along the y direction? Minus G. What is the initial velocity along the y direction?
U sin theta.
Absolutely,
U sin
right? So now we know S is equal to ut plus half at square. So here I can write y is equal to uy into t plus half ay into t square. And I can substitute the values and simplify, okay? I'm going to present that to you. So y is equal to y naught plus uy into t plus half ay into t square. Y naught is initial any y displacement which might be there. So in this case, it's starting from origin. Therefore, this value is 0. Ay is minus g and uy is u sin theta, right? So u sin theta into t. That t is nothing but capital T by 2, which is u sin theta by g, plus half into acceleration is minus g, right? Because it is in the downward direction, into t square. T is u sin theta by g, the whole square. So what do we get? U sin theta into u sin theta, that is u square sin square theta by g, first term, minus second term is half u square sin square theta by g square will be there into g. So g gets 1g gets cancelled. So you get this. So if I take u square by g sin square theta outside, I'll get 1 minus half, which will be half. Thereby I get h's value is to be u square sin square theta by 2g. So the equation that we have used here is S is equal to ut
plus half at square.
Correct.
So we can also use v square equals u square plus 2as, right?
Exactly. So in that case, the benefit of that formula is, using that is, you don't have to know time, right?
Yes.
So yes, absolutely, that's right. So v square is equal to
U square plus 2as.
2as. See at the topmost point here, when I'm talking about v, it is vy. Is it clear?
Yes, sir.
Yes.
Yes.
So what is vy at the topmost point of the projectile? At this point, what is vy? What is the velocity? Y velocity?
0.
0.
0, absolutely.
0, sir.
Correct. And
U
uy,
sin
what is the
theta.
initial velocity?
U sin theta square.
Yeah,
U
u
sin
sin
theta
theta
square
whole square minus 2g into
H.
yes, directly you get this, right? So 2gh will give you,
U square sin square theta. And H is equal
and
to
this
U
directly
square sin square
implies
theta by
h is equal to
U square sin square theta
theta
by
by 2g.
absolutely. So this is a better result to use or better way of deriving. This is all, nevertheless, this is also a right approach. But only prerequisite is you need to remember the time of flight for doing this way. Is it clear?
Yes, sir.
You may do it either way, you'll be awarded marks. Clear? Any doubts?
No, sir.
Yeah, I'll give you a minute to take it down. Okay, in the coming sessions, I'd recommend all of you to be on video so that we give a live class experience. Okay, let's go to the next one, guys. Any doubts in the previous one? Is everyone clear about this?
Yes, sir.
Excellent. Okay. Next question, question number 9. State Newton's laws, the second law of motion, and hence derive F is equal to ma. Pretty straightforward question. So what is it? How do you start? The statement carries 1 mark and the derivation carries 2 marks.
Newton's second law of motion states that when a motion is traveling in when a body is traveling in a straight path, it continues to be in that state of motion unless an external force acts on it.
Is that your second law?
Yes, sir.
Rate of change of linear momentum is
Yes, ma'am.
force on the body.
Yes, absolutely right. What you initially stated was Newton's first law, right? Inertia, law of inertia.
Yes, sir. Yes, sir.
So this is second law. Second law quantitatively gives you what is the value of force, right? So could you come again? What is Newton's second law statement?
The rate of change of linear momentum is directly proportional to the force acting on a body.
Yes. The rate of change of linear momentum is directly proportional to the external force which is acting on the body. Absolutely. Right. So you could do this derivation in 2 ways. Okay. Once you derive, of course, the statement, once it's given, you could derive it in a couple of ways. One is you can write F as, this is the average force, right? Where your change in momentum is nothing but mv minus mu divided by the time. Mu. So your change in velocity becomes, change in velocity by change in time becomes the acceleration. So you can say F is equal to ma. Of course, it's proportional, in fact. So you always have this k term here. And in SI, the value of k is going to be 1. Okay. Now the other way, this is average force. Okay. You could have used this. Or you can also use instantaneous force. F is equal to dp by dt. So your momentum, linear momentum is nothing but mass into velocity, right? So this you will do it using UV method, product rule in differentiation. So it's m into dv by dt plus v into dm by dt. Okay. Now, usually if you see, this part is usually 0 because mass is constant in the cases that we discuss, right? But there could be situations where mass can be a variant, right? In which case you should be using this, right? So whenever mass is constant, then this can be, this becomes 0 because differentiation of a constant is 0. Then this becomes m into dv by dt, and dv by dt is nothing but instantaneous acceleration. Here delta v by delta t is actually average acceleration. Okay. Okay. And there is a k here. And the k value is 1. Okay. So you could have done either of them, you would have been awarded marks. I think somebody has to be on mute, guys. Okay, students. Now, so first is the statement. It states that the time rate of change of momentum of body is equal both in magnitude and direction to the force imposed on it. Clear? Now the derivation goes like this. Rate of change of momentum can be written as m into change in velocity by time. I'm sorry. So m into v minus u by t. According to Newton's second law, F is directly proportional to the rate of change of momentum. So that's m into v minus u by t. Proportionality can be replaced with k. So it becomes F is equal to k into m into a. A is v minus u by t. All right. But a we know is rate of change of velocity, which is acceleration. and K is a constant of proportionality. When you substitute M is equal to 1 kg, A is equal to 1 meter per second square, and F becomes equal to 1 Newton. So you will be able to find out the value of K as 1, and resubstituting that back in the equation, we get F is equal to ma. This represents the second law of motion. Is that clear to you, everybody?
Yes, sir.
Yes, sir.
Yes.
Yes. I'll just keep it on for a moment for you to note it down. Okay, next question. Question number 10. Give reasons for the following. Why is it easier to pull rather than push a lawn roller? Anybody can tell me more?
Rough surface, sir.
Sorry?
Because of rough surface.
See, a rough surface is same, right? Whether you are pulling it or pushing it.
Sir, the force applied will stop the rolling objects.
May I know who is interacting?
Sir, Joel.
Joel, tell me, ma.
Sir, because we apply the force on a rolling object, the surface will stop the movement, sir.
See, Emma, let me give a long explanation, but that explanation is not needed. I'll also tell you what you need to answer because it's a 1 mark question, right? It's a 3 marker. So for the first one, what you need to answer, I'll tell you. But had it been it can also be a 3 marker on its own. Okay. So the question is, if you're going to pull the roller, right? It is easier compared to pushing it. Okay. Let's see now. If I'm going to draw the free body diagram, who can help me with what are the forces acting on this mass?
mg is acting downwards.
Yes,
and
yes,
upward.
Emmanuel. So mg is acting downwards, then
N is upwards.
Tension.
tension,
Normal-
yes, okay.
Normal
Or in other
reaction-
words, here it's not hanging anywhere. So I'm applying a force, yes, F, okay.
normal reaction.
Exactly. So there is going to be a normal reaction, correct? Okay. Now,
And u sine theta.
sorry,
mg sine theta.
where is mg sine theta?
Okay, that's if you pull it. Okay, never mind.
Okay. Suppose if there is a theta here, all right. Now, this F can be split into what components?
2 components.
Yes,
Yeah.
what are they?
Horizontal and
F
vertical.
cos theta and F sine theta.
Yeah, so this will be your F cos theta, am I right?
Yes, sir.
And what will be a F sine theta? It will be vertical, right?
Yes, sir.
So F sine theta will be here, correct? Okay. Now, let's say the roller is going to move this way. So friction is going to act in this direction, correct?
Yes, sir.
So friction, what is the relation between friction and normal reaction?
Mu kn.
Yeah, mu into n, right? So here the object is moving, so it's mu kinetic. Kinetic, coefficient of kinetic friction multiplied by normal reaction, right?
Yes.
Now,
sir.
can you tell me what is n here? See here, what are the upward forces?
Normal.
Impact force F sine
N
theta.
and F sine theta, is it not?
F sine theta.
Yes, sir.
Yes.
And what is the downward force?
mg.
mg.
And they both are perfectly balanced. That's why the roller is not having any vertical motion, yes or no?
Yes, sir.
So, what is your n plus F sine theta?
mg.
Mg, right? So, what is your n equal to? Mg minus F sine theta, is it not?
Yes, sir.
So friction is equal to mu k into mg minus F sine theta. Yes.
Yes, sir.
And the force that is responsible for overcoming this friction or pulling the roller is F cos theta. Correct or not? Do you agree?
Yes, sir.
Yes. Okay, fine.
Yes, sir.
Now, just keep this in mind. Okay, let's say this is case one. Okay. Now let's say we are going to push the roller on the other hand. Okay, I'm going to apply a force here in this direction. I'm sorry. So I'm going to apply a force in this direction and push the roller. Okay, so F is in this direction, right? So F is in this direction. Let's say the angle is theta. Then what is this? What is this component?
F cos theta.
Now F sin theta is in which direction?
Downwards.
Downward direction. Yes, it is F sin theta here. And what about your mg? Which direction is it going to be?
Downwards.
Yes, mg is also going to be downwards. And a normal reaction is upwards, correct?
Yes, sir.
Yes, sir.
This is case 2. Now in this case, can you tell me, let's say this is N1, let's say this is N2. Now in this case, can you tell me, so the vertical forces are perfectly balanced, yes or no?
Yes, sir.
What are the vertical forces? Can you tell me? N2,
Normal reaction, mg and
F sin theta, right? So N2 is upward force and the downward forces are mg and what?
F sin theta. So
What is your
mg
N2 equal to?
mg plus F sin theta.
Can you compare the two normal reactions? In this case, the normal reaction is more or not?
In the second case, it's more.
That means when you're pushing it, the normal reaction is more, because of which, what's going to happen to your friction in the second case?
It's going to
The
increase.
friction will increase.
Exactly. So friction is increasing, then you have to apply more force, yes or no?
Yes, sir.
So did you understand that it's easier to pull than to push a lawn roller? This
Yes,
is how
sir.
you should have answered had it been a 3-mark question, okay? But now this was a 1-mark, this was the 3 questions were given 3 marks together, right? That means it carries only 1 mark. So what's your simple answer that's expected of you?
The friction
Because the net
very
force
high.
is higher when we are pushing the lawnmower.
Yeah, or in other words, why is your net force higher? Why it has to be higher? Friction is more when you push the lawn roller, that's all. So what's the answer you should give?
Friction is higher when you are pushing the lawn roller.
Compared to when you're pulling it, that's all. Or you can say friction is less when you're going to pull it, clear? That's the simple answer you should have given for the first one, right? Had it been a 3-marker, you should have explained all these. Okay, next, second one, static friction is a self-adjusting force. Why?
Because it is able to adjust itself according based on the force that's being applied on it.
Absolutely, right? So as you increase the applied force, the friction also is going to increase itself exactly to match that force. So the net force is 0, right?
Yes, sir.
And this happens till the applied force is not greater than
Static friction.
the limiting friction, the value of
Yes.
maximum value of the static friction. Clear? Yes, that's absolutely right. Third one, a cricket player lowers his hand while catching a fast moving ball. Why?
Because it will reduce the impulse.
Yes, it reduces the impulse force, right? So that's how you needed to answer this, right? So let me just show you what are the expected answers. So force of friction is more in case of push than in case of pull. That's it. That would be the answer which will fetch you 1 mark. And the next one is static friction is called self-adjusting force because as the applied force increases, static friction also increases and net force on the object becomes 0. This happens until the external force exceeds the limiting friction. Clear?
Yes, sir.
Yeah. Next, a cricket player lowers his hands while catching a fast moving ball. Why? By lowering his hands, the time of catch increases. So delta T increases, right? So impulse
Yes,
is given by F into delta T, right? F is equal to change in momentum by change in time. So this is called impulse force. So what happens is when you lower the hands, you're actually increasing the time here. So the moment you increase the time here, this is increased, this is going to be, the impact is going to be less. The force exerted on the hands becomes much smaller. So it does not hurt the cricketer much. Is that clear?
Sir, can I put impulse is inversely proportional to time?
Yes, because momentum is constant. Absolutely. Yes, Jerry, correct. Great. All right. So now we come to long answer questions. Any doubts still here, the friends? Is it all clear to you?
Yes, sir.
Yes, sir.
Okay, great. Let's look at the 11th question. Derive an expression for magnitude and direction of resultant of two vectors A and B. The angle between the two vectors being theta. Right. So I'm just going to list this to you. So you need to draw a diagram, and then you need to mark the angle clearly, mark the points clearly. So let's say this is a parallelogram. OPSQ is a parallelogram. OP and OQ are adjacent sides of a parallelogram. A vector and B vector. This explanation is very, very important, guys. Okay. Consider two vectors A and B, incline an angle theta. Let OP vector and OQ vector represent A vector and B vector respectively. Then according to parallelogram law of vectors, we know that OS vector, which is the diagonal of the parallelogram, represents the resultant R. Now construction. Draw SN perpendicular to OP, right, which is produced to meet at N. Then magnitude of the resultant R is going to be given by from the right angle triangle SNP, correct? We have SN divided by SP, which is nothing but opposite by hypotenuse. That is nothing but your sine of the angle theta. So sine theta is equal to SN by PS, or SN is equal to PS sine theta. But what is PS? It is same as B, right? So it will become B sine theta, right? Now, adjacent divided by hypotenuse. Pn by PS will be your cos theta. So Pn will be equal to PS cos theta, or Pn is equal to, PS is nothing but B cos theta. So Pn is B cos theta, Sn is B sin theta. That's what we got till here. Now we are going to apply Pythagoras theorem to this triangle ONS, the bigger one, right? So if you see, that's nothing but ON square plus NS square. ON can further be written as OP plus PN, right? Whole square. OP is nothing but your A, and PN is nothing but we just got it as your B cos theta. So now what will happen? So this will be A plus B cos theta whole square plus B sin theta whole square. So that will be A square plus B square cos square theta plus 2AB cos theta, A plus B whole square formula, plus B square sin square theta. Now if I'm going to combine B square sin square and B square cos square, we'll get B square, because cos square plus sin square is 1. So you get this. This is your final expression. So R square is equal to A square plus B square plus 2AB cos theta. So R will be equal to root of A square plus B square plus 2AB cos theta. And how do you find the direction of the resultant? Let's say the resultant makes an angle alpha with your x-axis, or in other words, your first vector. Okay. Then what is going to happen? Your right angle triangle ONS, if you see, what is your tan alpha? Opposite by adjacent. Opposite is SN, adjacent is ON. So that's ON can be written as OP plus PN. So that's A plus B cos theta in the denominator, and numerator is going to be B sin theta. So that's going to give you the direction of the resultant, or in other words, alpha can be written as tan inverse of B sin theta by A plus B cos theta. This is what you must have done. For diagram, you would get 1 mark, and then your explanation here 1 mark, derivation of the magnitude 2 marks, and then the resultant 1 mark. So that's how 5 marks will be awarded to you guys. Clear? Any doubts in this?
No, sir.
All right. Shall we move on? If you want time to take it down, I'll give you a minute.
I'll take it, sir.
Have you taken down? Okay, students, let's move on now. Okay. Next question is, show that the trajectory of a projectile is a parabola. This has also been asked many, many times. So let me just quickly take you through this. So consider an object projected at an angle of theta and having an initial velocity u with the horizontal. Okay. Then we know this is u cos theta and this is u sin theta, your horizontal and vertical components. And the horizontal distance x, which is traveled at any time, is given by x is equal to u cos theta into t. And your y is going to be given by ut plus half at square, where y, which is nothing but your initial vertical velocity u sine theta, that's u sine theta into t, plus half into minus g, because your acceleration due to gravity is in the negative direction, t square, right? So it's u sine theta into t minus half gt square, and your x is u cos theta into t. So t can be written as x by u cos theta. That I can substitute here. So that gives you your final result. So you get y is equal to x tan theta minus half g x square by u square cos square theta. You see one of the g's getting cancelled. Now this equation is very similar to form y is equal to ax minus bx square, which is the equation of a parabola, where a is tan theta and b is g by 2u square cos square theta. Clear, students?
Yes, sir.
Yes.
Yes, sir.
Yeah. For the benefit of everyone, I'll just. So you have your projectile, right? So let's say this is your initial velocity. What is the angle it makes with the x-axis?
Theta.
Theta. Then this can be resolved into two components. What are they?
U cos theta and
Theta
U
and
sin
sin
theta.
U sine theta, right? Those are the initial velocities. Now at any point, wherever the projectile is, it can be represented by how many variables? Coordinates, x and y, right? Now this goes using the formula s is equal to ut plus half at square.
Half at square.
Exactly. First we will do for the displacement x. So x will be equal to what? Ux into t plus half ax into t square. Now because there is no horizontal force acting, there is no horizontal acceleration, therefore this component will become 0 because ax is 0. So your x is equal to ux. What is ux?
U cos theta.
Exactly. So that is nothing but u cos theta into t.
Excuse me, sir.
Yes, Jaril?
Instead of using ut plus half at square, can we use speed is equal to distance by time only for the x-axis?
Right. So that, see now, first of all, here what happens is, that's absolutely right. But that will be different if your acceleration is present.
Okay, sir.
Yeah. So it works because your acceleration is 0. It won't work for your y velocity or y.
Yes, sir.
Got it? Yeah. Yeah, you can use it in this case.
For x-axis.
Yes, yes. Because the acceleration is 0, right?
Yes, sir.
Yes. So what is your y going to be equal to? Uy into t plus half ay into t square. Here, what is your uy? U sine theta into t plus half into what is ay? Minus g t square. Now, the value of t, you're going to get it from the x. So what is your t equal to?
X by
x
U
by
cos
u
theta.
plus theta.
Exactly. So that I'm going to substitute for t here. Okay. So what are we going to get? U sine theta into, in place of t, I'm going to write x by u cos theta. Plus into minus is a minus. So half g, and what is t? X by u cos theta. So t square will be x square by u square cos square theta, right? So you can see that u and u cancel here. So we are getting y is equal to x sine theta by cos theta. What is sine theta by cos theta?
Tan theta.
Tan theta.
Right? Minus g divided by 2u square cos square theta. into x square, right? So this is looking very similar to y is equal to ax minus bx square, correct? So it
Yes,
has a
sir.
quadratic relationship with x, right? So this is equation of a parabola. Hence, we are able to prove that the trajectory of projectile motion is a parabola. So where A is equal to tan theta, and what is your B?
G by U square cos square theta.
Cos square theta, right? This is what is expected. So for diagram 1 mark, for getting your x 1 mark, and then your y plus getting to the final result, right, of this form. So you're going to have 3 marks, right? So that's how the mark distribution is going to be. A very, very easy question which you can score fully. Any doubts, students?
No, sir.
I'll give you a minute to take it down, then we'll move on to the numerical questions. Okay, now let's move on to the next question. Fine. So now we have the numericals, right? Question number 13. So as you know, there are 4 numericals. First part 2 numericals, second part 2 numericals, and you have an internal choice, right? So let's look at each of them, right? A mass of 5 kg is moving with a velocity of 6 meter per second, collides with another mass 2 kg, which is at rest. So as you can understand the scenario, so there is a mass. What is its value? What is the mass?
5 kgs.
5 kg. And what is its velocity?
6 meter per second.
Yeah, 6 meter per second. This is going to collide with another mass. What is the mass of the second one?
2 kgs.
2 kg.
2 kgs. And what is its initial velocity?
0.
0, because it's given that it is at rest, correct?
Yes. Yes.
Now, the moment the collision happens, after the collision, they both are going to move in the same direction, right? Which is, let's say, towards the right in this case, what we have assumed. Now, in the second case, so what's going to happen is, so after the collision, your mass 2, your 2 kg mass, is going to move with a velocity v2. What is its velocity?
10 meters per second.
10 meters per second. Then, what is going to be the velocity of the 5 kg mass? That's the question. That's the first part of the question. And finally, you're also asked to find the kinetic energy of the mass, correct?
Yes.
So what's the principle we'll be applying here?
Law of conservation of momentum.
Yes, law of conservation of linear momentum, because there is no external force acting on the system. Therefore, whenever the external force acting on the system is 0, momentum is conserved. That means momentum, initial momentum is going to be equal to the final momentum. What is the initial momentum?
M1 U1 plus M2 U2.
Yeah, so that's going to be equal to
M1 B1 plus M2 B2.
exactly. Right? So M1, M2 U2 is going to be 0. So what is your M1 U1? 5 into 6 is equal to 5 into, we don't know what that value is, V1. So let's keep it as V1 itself. M2 is 2 into 10, 20. So 30 is equal to 5 V1 plus 20. So what is your 5 V1? 30 minus 20, which is 10. So which implies V1 is equal to 2 meter per second. So that's the first part of the answer. Second part of the answer is finding out the kinetic energy. So here the mark allotment will be For getting the law of conservation of momentum, 1 mark. Getting the velocity, 1 mark. And your kinetic energy, 1 mark. Because it's 2 parts, the other question is going to carry 2 marks. Half mv square, so that's going to be half
square.
into, what is your mass?
5 into
V
2
square, so that's going to be 4, 20 by 2, 10 joules, right? So it's going to carry 1 mark as well. Is this clear to you guys? Any doubts in this?
No, sir.
Okay. I'll give you a minute to take it down, then we'll move on to the next part.
Yes, sir.
Yes. Okay, next one. A cricketer can throw a ball to a maximum horizontal distance of 100 meters. So when I say maximum horizontal distance, what is that? In a projectile, what is that? R, correct?
Yes, sir.
R is given to be 100 meters. It's not simply R, but R max. What is the formula for R?
U square sine 2 theta by g.
Exactly. Now,
So
for R to be maximum, what should be sine 2 theta?
Sine
2
to
45 degrees.
45.
Yeah, theta is 45. Very good. Sine 2 theta will
Theta
be
is
1. So U square by G is equal to
R max.
R max, which is 100. Or in other words, U square is equal to 100 G. If I take G as 10, then it will be 1000 meter per second, the
Yes,
whole
sir.
square, because it's
If
U
they don't
square.
specify 9.8 meters per second square,
Yes,
can
no
we
problem.
just take it as 10 meters per second?
Yes,
they don't
yes. Either
specify.
way is fine. Either way is fine. If you take it as 10 meter per second square or 9.8 meter per second square, that's fine. Either way, you'll be given
Yes.
marks.
So if they don't specify it, we can just write 10 meters per second square.
Yes, yes, no problem. Okay. Find the height reached by the projectile in this case, right? So what is going to be the maximum height? What is the expression for max height?
U square sine square theta by 2g.
Yeah, U square sine square theta by 2g. Right? So your U square is already ready with us, 1000. Sine theta is what? Theta is 45.
45.
Sine theta is 1 by root 2. Sine square theta will be 1 by 2. Then I have a 2, then a g here, right?
So the square.
Then we'll get cancelled. 100 by 4. So that's going to be 25 meters. Is that clear?
Yes, sir.
Yes, sir.
The same ball, if the guy is going to throw it vertically, then what would be the maximum height attained, right? So if a guy is going to throw vertically, I hope you know, right? If I use V square, I'm just deriving it, but then you should know it by heart, okay? At the topmost point, what will be the velocity? Vertical throwing.
0, sir.
0, absolutely.
0, sir.
Right, right. And initial velocity is U square, and acceleration is nothing but your acceleration due to gravity, which is against the velocity, right, as it is going up. And the displacement, which is the maximum height, is h. Let me call it as, you know, a vertical projection. So I'm just marking it as V, okay? So what is your HV equal to? U square by 2g, correct?
Yes, sir.
So 50,
Yes, sir.
50
You put it
meters.
directly return, right? So that's 1000 divided by 2 multiplied by 10. So 1000 by 20, that's going to be
50 meters.
50 meters, absolutely. Right? For getting your U square half a mark, for getting your H 1 mark, and then for getting your HV half a mark, this is expected to be remembered. You don't need to do this derivation. Clear? So put together, the sum carries 5 marks. Is this clear, students? Once you have taken
Yes,
down,
sir.
just
Yes,
let me know.
yes, sir.
Great. Okay, let's move on. Okay, we have another question here. A particle starts from t equal to 0 with a velocity 5 meters per second. So ux is equal to 5 meter per second and moves in xy plane and under the action of the force which produces a constant acceleration. What is the acceleration? (3i plus 2j meter per second square). What is the y coordinate of the particle and the x coordinate is 84 meters, right? So what is y equal to? Uy into t plus half ay into t square, correct?
Yes, sir.
Right. And what is your x equal to? Ux into t plus half ax into t square. What is the acceleration along the x-axis?
0.
No, not 0. In this case, 3. 3 is the acceleration along the x-axis. And your initial velocity along the x-axis 5. So 5t plus half 3t square is equal to, what is the x distance? 84. So when you take the LCM, it's going to be 84 is equal to 10t plus 3t square divided by 2, or it is 3t square plus 10t minus 168 is equal to 0. In fact, you will find out that 28 into 6 is going to give you 168, or 28 into 18 is how we are going to split this. So this is 3t square minus 18t plus 28t minus 168 equal to 0. Alternately, you can do minus b plus 1 minus root of b square minus 4ac by 2a. So I can take 3t common outside, I'll get t minus 6. The next one also I'll get t minus 6. So I'll get two options. T can be either 6 or 3t plus 28 is 0, which means t can be either 28 by 3. I'm going to neglect that option because time is not going to be negative because it starts from 0. So t is equal to 6 seconds. So now we can, using that, we are going to solve this. Your initial y velocity is 0. So it's simply half into ay. What is your ay? 2. And time is 6. So 6 square, 36. Therefore, the y displacement is going to be 36 meters. Is it clear, students? So you're given the x value, you're given the ux,
Yes.
you're given ax. You just need to find y. Any doubts in this?
No, sir.
No, sir.
Okay, we'll move on, guys. Okay, last question in the paper. Of course, the first one carried 3 marks, and now this one would carry 2 marks. So first one is find the instantaneous velocity and acceleration. So each of that half a mark. Okay. So this requires differentiation. So velocity is equal to dr by dt, which would be nothing but differentiation of 3t. 3t differentiation is 3 minus 2t square differentiation is 4t. And 4 is a constant, differentiation is 0. See, if you're differentiating with respect to t, t power n differentiation can be written as nt power n minus 1. Differentiation of a constant is going to be 0. Differentiation of constant multiplied by t power n will be t, k you keep it as it is, nt power n minus 1. So these 3 things you know, you'll be able to do simple sums in physics which involve differentiation. So using these, we have got the velocity expression, meter per second. Acceleration. So this has been asked in PU board exam. dv by dt, you're going to differentiate this further. 3 is a constant, you differentiate 0. Minus 4t, you differentiate, you get minus 4 meter per second square. So this is the answer for the first part of the question. Now, second part, we are interested in finding the magnitude. So now t is equal to 2 seconds. So wherever t is there, you should substitute 2. So it is 3i minus 4 into 2j cap. That will be 3i minus 8j cap. That will be your vector. But then magnitude, when you have to find, will be root of a square plus b square. So 3 square plus minus 8 the whole square. So 9 plus 64, that will be root 73. You can leave it like that. Meter per second. Finally, we'll find out the acceleration. Acceleration, you can see, is not dependent on time, right? It is minus 4j cap. There is no time factor in that. So it remains minus 4j. And when you want to find the magnitude, j cap magnitude is 1. It's a unit vector along y-axis, right? Therefore, it is going to be simply 4 meter per second square. So that's all. So that will be the answer that will be expected of you. For applying differentiation, you need to use these formula. Is it clear, students? Any doubts?
No, sir.
Yeah.
No, sir.
Okay, students, fantastic. So I'll share which which year all these questions have been asked, and I'll also share the other derivations which will be helpful for you. Okay. So I will congratulate all of you who had been part of this session. All the best for your exam tomorrow. I'll acknowledge all of you once, who have been here. Savita, Teja, Mary, congratulations. Abigail, Alvin, Devraj, Emmanuel, Jeril, Joel, Kagan, Kelsey, Leah, Meda, Leena, Reena, Saumita, Sumana, Vinaya. Congratulations, guys.
Thank you.
Keep participating and learning. All the best for your exams. My only recommendation is, from going forward, you need to be on the videos, guys. Okay. All the best. Have a great examination tomorrow. Take care.
Thank you, sir.
Thank you, sir.
Bye.